Okay, so I just want you to know that I'm recording this. You should see a PowerPoint slide. How many of you see that?
I see it.
I see it.
Is there
Yeah, I see. I see.
I do.
anything else interfering with your view? Because I have two other things up.
No.
Just
No.
nothing else. Good. All right. So really, this lecture is a short lecture, and it's just to start you going on the concept of assessments. And in terms of hot topics and personality, I'm actually pulling that so that you can have a robust discussion within your groups. And I can also pop in. So let's start with variables. So again, when you have questions, you could ask questions in many different ways. You could ask questions with fixed alternate responses. Long story short is that is giving the respondent a set number of choices to answer. The most common example that I can give you of this is a demographics questionnaire, right? So you ask people to select their gender. Now, you could have people write in what is your gender and have a open text box, but that's not probably going to be helpful for coding because you're going to have to recode all of that. Instead, you might have choices like male, female, transgender, gender fluid, prefer not to answer, right? So you could give options, and when you do that, it's a limited number of choices it can select from. Does that make sense? What a fixed alternative is? Okay. The alternative to like a closed-ended or fixed alternative questions are open-ended questions. Now, when you use open-ended questions, the benefit is that people can answer it any way they want. And by answering it any way they want, there is the capacity to get richness and depth in answers. You're not restricting their responses in any way. The biggest problem with using open-ended questions is that you need to develop a coding system, or you need to develop a way of analyzing the responses in a meaningful way. So it's a trade-off. You can either get breadth and restrict the answers, or you could get depth and then have to figure out how to code it. Now, rating scales, you might hear these referred to as Likert scale questions. These are spectrum-based answers. If you've ever filled out a survey, strongly agree, neutral, disagree, or strongly disagree, if you've ever done that, then you likely have dealt with a rating scale. Now, Likert scales is a kind of a rating scale, as I mentioned, but it's levels of agreement. We also have something that are semantic differential scales, where we put words on bipolar opposites, and then you could reflect on that. So let's say you put on one side of a poll introversion, and on the other side of the poll extroversion. It could be spectrum based, and you could measure the distance or how closely they mark being introverted or extroverted. Agreeable or confrontational, you could put that on polls. And so semantic differentials are good because you can measure psychological distance between the polar opposites. Now, whenever you do a survey, you have to be careful with the concept called social desirability. When you ask people questions, people are likely going to tell you what they think you want to hear. They're going to want to please you, or they're going to tell you that which they think society approves of, and they're not likely to endorse the kind of things that society disapproves of. So, being socially desirable, I think we touched upon this briefly, is just trying to um, respond in a way that presents you in a favorable light. Now, response sets don't always have to be a social desirability response set. They can be a yay saying or nay saying response set. So you could just say yes, 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 all the way down, no, 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 all the way down, strongly agree, all the way down, right? So these are response sets where you answer in a patternistic way, but not really reading the details of the question. So, how do you deal with response sets? How do you deal with social desirability? Well, for social desirability, you can emphasize anonymity. Hey, the survey's anonymous, no one will know your answers. People are more likely to be truthful if it's an anonymous survey. But you can also do other things to test for social desirability, such as altering the wording on some items. You may have heard the term reverse coding. Reverse coding is a way of phrasing a question to the opposite of what strongly agree would mean. So if you had a question that said, I love ice cream, and you click strongly agree, and then way down in the questionnaire, you have a question that says, I hate ice cream. Well, if you said strongly agree to liking or loving ice cream, then you should say strongly disagree. So altering the wording to the opposite requires you to answer in the reverse. So we can detect response sets by wording things in the reverse. We also can break you out of response sets by including irrelevant items. You might hear them called as filler items. And then there's also something I like to do, which is called a quality check. So for some items, you might say, for this question, click neutral, right? So if they click strongly agree, when it says specifically what they're supposed to do, it could tell you that they weren't reading and they were just answering from a response set. So that's something you could do to as a check and balance against a response set. Now, when you're observing behavior, you can score a person's behavior in many different ways. Things like accuracy. Did they answer correctly or incorrectly, right? Things like frequency. That's the how many times a behavior occurs. Things like latency. How long did it take from the beginning to start doing the behavior? For example, I can detect latency on the test based on how long it took you to open up the test. It was uh, accessible to you starting at 6:30. If you got in at 6:32, then your latency would be 2 minutes. I could also measure duration, how long you did the behavior. So I could tell how long you were in the test. So if it says you used 8 minutes to complete the test, that's the duration. Does that make sense? So latency is how long it took to start a behavior. Duration is once you started a behavior, how long that behavior lasted. Amplitude is the strength of the behavior or the size of the behavior. And choice selection is frequency of given a certain choice over the alternatives or another choice. So we also have concepts called quantitative and qualitative variables. Quantitative variables are variables that you analyze them using numbers or amounts. So you can determine more or less of a variable, right? Whereas qualitative variables, they're used in categories. They use different qualities. They use words to describe the variable. So qualitative variables could be categories of gender, right? Categories of ethnicity, political party. So you wouldn't necessarily look at greater than, less than. Now you can get frequency counts on some qualitative data, but quantitative variables are designed to determine more or less of a variable, or things like means and standard deviations. So that brings me to our scales of measurements, or levels of measurement. In 201, you probably learned that there are 4 scales of measurement. And you probably learned a mnemonic for this, noir. So if anyone speaks French, you know noir is a word in French. So it means dark or black, right? So that's a mnemonic for the 4 scales of measurement, or levels of measurement. Now I'm going to say something now that I want you to write down, because it's going to come up later in the semester. In SPSS, which is your statistical software program, you do not have 4 options for levels of measurement. In SPSS, there's only nominal, ordinal, and scale. Those are your 3 choices in SPSS. And what you're going to hear me say now, and what you're going to hear me say when I talk about the SPSS and how to navigate that software, is interval and ratio data are treated as scale. So let's go through it conceptually now, and I'll remind you of this when we get into SPSS again. So nominal means in name only. So they differ in name or category. So these are qualities of the participant, right? So there's limited statistical manipulations you could do. So from a descriptive statistics point of view, you can get the mode, you can get the most frequently occurring score. So what is the most common eye color in the class, or what's the most common gender in the class? But that's hard to really do anything meaningful in terms of statistics. You get just most frequently occurring. In an inferential statistic, you might be able to do a chi-square, whether the frequencies are significantly different than what you would expect by chance. But in general, these are not meant to be better than, worse than, significantly greater, comparing means. It's just categorical differences. By the time you get to ordinal data, now things are put into rank order. So if you think swimming, you have first place, second place, third place. We know the person who performed and earned first place in a swim meet did the best. Their performance was better than the person who came in second place. And the second place individual performed better than the third place. So now we could put you in rank order: better than, worse than, greater than, less than, in a meaningful way. However, one of the biggest challenges with ordinal data is the units of measure are not equal. The units of measure in ordinal data are not equivalent. And that's important to know, because the distance between first and second place might be very different than second place and third place. For those of you who like swimming, the most decorated Olympic athlete for swimming is Michael Phelps. And in one Olympics, the Beijing Olympics in 2008, he earned 8 gold medals in that Olympics alone, tying Michael Spitz. But I bring up Michael Phelps because when you look at his races, there were some races where he might have been 3 body lengths ahead of the next person. So there was a big difference between first place and second place. But the silver medalist and the bronze medalist, it might have been a finger's breadth. Just one person touched the wall in a millisecond faster than the other. So when we talk about ordinal data, we can put you in rank order, but or greater than, less than, but the units of measure are not equal. So when we think about descriptive statistics, the statistic that it lends itself to is the median, right? And when we do ordinal data inferential statistics, we can do some non-parametric statistics, which means that we're not assuming a bell-shaped curve, but it's very limited. And in fact, when you took your statistics class, you probably learned that when you have complex research designs, there are some cases where we don't even have a statistic to answer the research question if you're using ordinal data. So ordinal data is sort of like in between. Now, if the swimming example did not resonate with you, I'd like to give you another example. Hotel accommodations. So if you were traveling, you probably would look at the number of stars the hotel has. And it's understood that within a given region, the more stars you have, the better the hotel is for that area. So we assume that a 5-star hotel is better than a 4-star hotel. A 4-star hotel is better than a 3-star hotel, and a 3 is better than a 2, and a 2 is better than a 1. So the more stars, the better we believe that hotel is. Now, about how much better is it? Well, if you've gone to hotels, you probably will see a very big difference between a 1-star and a 2-star hotel. What does a 1-star hotel look like? You probably wouldn't call it a hotel. You probably would call it a roadside motel. And you probably have to pay extra for the roaches, which is that's a joke, people. You may or may not have clean sheets. It is just bare minimum, just a place to lay your head. A 2-star accommodation, now you probably have a lock that works on the door, probably very minimal amenities, but you feel a little bit more safe there. By a 3-star hotel, you have all of the previous things, but now you might have a breakfast, a continental breakfast, like a Hampton Inn situation. You might have clean towels, a clean shower. By a 4-star hotel, then you start to get potentially a restaurant in the facility, dry cleaning services, and then the difference between a 4-star hotel and a 5-star is negligible. But what you notice as you go up in stars, the difference gets smaller and smaller. So the quality, if you are if you are traveling on a budget, a 3-star hotel is the sweet spot, right? It tends to be, it has everything you need. It's not dingy, but you're not overpaying, right? So that tends to be, but notice how we can determine the quality of a hotel by number of stars, but each star is not valued the same. All right. Once we get to interval data, now we have equal units of measure. The only difference between interval data and ratio data, because they both have equal units of measure, is that interval data, 0 does not mean 0. What do I mean? Look outside your window and look at the thermostat. what is the temperature outside right now? If it's below 32 degrees Fahrenheit, you likely are dealing with sub-zero temperatures, right? When we talk about Celsius, right? But zero doesn't mean zero in temperature, because even 0 degrees Fahrenheit or 0 degrees Celsius, it's still not the absence of temperature. So there is no real zero there, or IQ. Even though each IQ point is worth the same, if a person got a 0 on an IQ, that doesn't mean they lack intelligence altogether. It just means the test couldn't measure it. So there are times when 0 doesn't mean 0. It's not an absolute 0 or a true 0 point. Whereas with ratio data, 0 is an absolute 0. So if you get on a scale, right, before you got on the scale, it was zeroed. It was at 0 weight. Once you get on the scale, each pound is worth the same amount. It's the same unit of measure, and there is an absolute 0. Or if you take a test, a quiz, and you get all 10 items wrong, you would get a 0, and that 0 is an absolute 0. All right, so that's interval and ratio data. When you're using interval and ratio data, now you can use all parametric statistics. So you can use the means and standard deviations for descriptive statistics. You can use things like t-test, ANOVA, regression equations, things like that for inferential statistics. So interval and ratio data are the most versatile in terms of statistics. Now, because the units of measure are equivalent, that's why SPSS refers to it as scale. And that's why SPSS lumps interval and ratio data into the same category. So, in terms of data collection and data measurement, you want to make sure that you have the most accurate portrayal or depiction of the population as possible. So when we talk about sampling, which I have a whole nother video on sampling, you want to make sure that your sample reflects the population. It's representative of the population. And that's going to allow you to generalize more readily. You also want to rely on statistics to draw meaningful conclusions about your sample as it relates to the population. So using statistics are going to be crucial. Now, we talked about reliability. I talked to you about test, retest reliability. I'm going to say it again, even though I sent you the videos. Test, retest reliability is giving the same test to the same people at 2 or more points in time. If the test has reliability, you should get the same or similar scores. One problem with test, retest reliability, though, is that it could be artificial. So you could remember your answers if you give the same test twice. So instead of giving the same test, there's a variation that you could use called alternate forms reliability. And in the case of alternate forms reliability, you give different versions of the same test to the same people and you correlate it. So now you've eliminated the problem of artificiality, right? It's the same concept, but different questions, so you can't remember the answers. But when you test participants at 2 points in time, you also have problems with that, such as tracking participants and making sure that they come back for the second test. So if you want to avoid dealing with testing at 2 points, you can use something called internal consistency reliability. And in internal consistency reliability, you're measuring people at 1 point in time. And there are 2 ways to do this. The most common way of doing internal consistency reliability is something called split half reliability. And that's where you just divide the group into two groups. So if you had a 60 item test, you split it into two tests of 30. And the way you split it into two tests of 30, I recommend you using odds versus evens. And the reason why you would use odds versus evens is just in case people got bored or fatigued. So that's better than doing the first 30 versus the second 30. Now, if you're scoring data and you want reliability, you might consider, if you're doing observational research, pardon me, using two raters or two judges. They should get the same or similar outcomes. Now, validity, we talked about face validity. Does it look like it's measuring what it says it is? We also have something called construct validity. In psychology, a lot of the things that we measure are theoretical in nature. If I were to ask you, what is personality? What is intelligence? What is love? What is happiness? What is altruism? The answer is that these are all theoretical concepts. So if I wanted to measure a theoretical construct like happiness or love, I might need to test whether that instrument actually measures something like happiness or love. So construct validity asks the question, does this measure actually measure what it claims it's measuring in terms of this theoretical construct? And there are ways to test that. Things like content validity. And this wasn't on the other lecture, but content validity is you look at the items and see if the items reflect whatever you're trying to tap into. So if you were trying to create an instrument to measure substance abuse, is it comprehensive? Do all the items address substance abuse? So content validity, you look at the actual items of the test. You do a deep dive. Is it comprehensive? And then the response options. Is it comprehensive? Is it appropriate? Now, for content validity, you create a panel of experts. So people who don't know what the test is about, you ask them to evaluate, A, what do you think the test is for the face validity piece? B, so what do you think it's measuring? B, are there any items you think are missing that you would want added? And 3, are there any response choices that you feel are missing? And you give it to a minimum of 3 people. 3 people are experts in the area to determine the comprehensiveness of your instrument. Now, we also have criterion and predictive validity. When we talk about this, this is how well your instrument can predict an outcome. I think in our review last class, we talked a little bit about SATs and GREs. Now, the next part of this lecture is all about talking about instruments. So you might hear the term test, scale, and inventory, and they mean different things, right? So a test refers to a procedure used to measure a variable, and that's a very generic term. A scale is used to measure a specific psychological characteristic. So it's oftentimes focused on one psychological factor, whereas an inventory is a host of scales, a host of psychological characteristics that you're measuring. And you might have remembered I used the term Minnesota Multiphasic Personality Inventory, right? So the MMPI, it measures 10 clinical scales, right? Remember I said that in the last lecture. So an inventory has multiple scales in it. So let's talk about some commercial tests. When we think about intelligence tests, there are many different intelligence tests out there. The first intelligence test that was put on the market was the Stanford Binet test. We learned all about Alfred Binet in terms of history and IQ testing. And that was the gold standard when we talk about intelligence until David Wexler came about. Now, David Wexler created 3 tests, actually. He had the WIPSI, WISC, and WACE. The WIPSI was for preschool age children from 2 to 6. The WISC was measuring intelligence for school age children from the ages of 6 to 16. And the WACE, Wexler believed that your intelligence is fairly even across the board from 16 plus. So we treat you like adults. So the Wexler test supplanted the Stanford-Binet, but there are many more. Another common one that's used is the Woodcock-Johnson test of cognitive abilities. They have an achievement form and an aptitude form. All of these include verbal and nonverbal actions. So if you're interested in test of nonverbal intelligence, you might use the Raven matrices test, the progressive matrices test. You might use the C-TONI, the comprehensive test of nonverbal intelligence, and many more. So when we talk about it, there are tons of instruments. Test of personality. So the MMPI we talked about in last class, that was originally created to measure psychiatric population. It has a lot of utility for psychological disorders, with the exception of personality disorders. So if you want to measure personality disorders, there's a great test on the market called the Milan Clinical Multiaxial Inventory, or the MCMI. Much better at measuring personality disorders. Another one that's good at measuring personality disorders is the PAI, right? Personality Assessment Inventory, very good. But sometimes you're not looking for pathology in personality. You might be looking at healthy personality. So things like the 16 factors of personality and the California psychological inventory, these are very good for measuring personality in general, identifying various traits. Now, we talked about projective tests as well in the last lecture. And I mentioned to you that the Rorschach was not the only ink blot. So there's another one called the Holtzman. We talked about the TAT, which was telling a story about a picture. Now, there is a childhood version of that called the CAT, the childhood apperception test, and it's meant to be more engaging, has animals instead of people, things like that to keep the kids involved. And then there's other specialized tests for physical development in infancy. So the Bailey scales are used for IQ from birth to 2. We also have geriatric depression scales. So people who are interested in late adulthood might want to measure depression in older adults. We have scales for bipolars, such as the Young Mania Rating Scale, and many more. So I'm going to stop my share and I'm going to ask you, what do you think the point of that lecture was? Right? The point of the lecture was to get you to think about your dependent variable and how you measure your dependent variable. So we talked about variables in general. We talked about how you scale a variable, and then we talked about instruments. I'm going to have a whole video on how to find instruments. Spoiler alert, there are 2 places that people oftentimes go to. One is called the Mental Measurements Yearbook. That they produce copies of instruments every 2 years and a review of those instruments. And a more common one for us is called Psych Test, PSYCTESTS. And it's all psychological instruments. So when you develop your research questions within your group, you're going to eventually have to identify instruments to answer the research questions. So what I've done now is the lecture portion. for the next hour, what I'd like to do is put you into your groups